Hi everyone, so in this video I just want to introduce some terminology relating to functions that we'll be using in class. Some of these terms may be familiar, some may be new. So let's just start with one of the main objects that we study in mathematics are functions. So a function is a mapping from one set A to a second set B, so that for every element in A, we get matched with exactly one element in B. So that's the key property that a mapping needs to satisfy in order for it to be a function. That is, each input gets mapped to exactly one element in set B, in what we'll soon call the codomain. And so some notation that we'll be using with functions, if f is a function from A to B, then we typically write A arrow B, meaning we're mapping from A into B. For each element in the set A, if there is an element in B which A maps to it, then we say that B is the image of A, or in other words, A maps to B. Okay, and lastly, when we're talking about the image of an individual element in set A, then we say A maps to B, and the arrow has a little vertical bar over here, as opposed to the arrow that we use here to denote the map from all elements in A to some element in B. Okay, so let's take a look at some examples and try and identify things that may or may not be functional relations. So first, let's consider example 1, where A is set 1, 2, 3, and B is the set 4, 5, 6, 7, and 8. And we're going to say f is the function that maps 1 to 4, element 2 to 4, and element 3 to 6. And we want to know, is this a function? And this is indeed a function. Since each element in set A, 1, 2, and 3, is mapped to some element in set B. So 1 goes to 4, 2 goes to 4, 3 goes to 6. So the fact that 1 and 2 both are mapped to the element 4, that does not violate the requirement for a function. We want to make sure each input has only one output. So 1 has only one output, 2 has only one output, 3 has only one output that come from the set B. So 1 is a function, no problem there. Next, let's consider the following function in 2. So let's now consider the same two sets, but now this mapping G takes 1 to 4, takes 1 to 5, takes 2 to 6, and takes 3 to 8. So now this one, in fact, is not a function, since we have the element 1, 4, the element 1 going to 4, and we have the element 1 going to 5. So the element 1 over here maps to two elements in B. So that makes it not a function. For a function, it can only map to one element in B. So that was a no for number 2. Next, let's consider the following example. So A is going to be the set of all students at CU Denver, and B is the set of all days in the year. Then we're going to consider the mapping from A to B, where each student is mapped to their birth date. And this would be a function. Again, what we want to make sure is each element in A mapped to one element in B. And so since each student has only one day that they were born on, each student in set A is going to be mapped to one date in set B. So that would be a function. And one more example in number 4. Let's consider A again being the set of all students, and B is going to be the set of all courses at CU Denver. And now we're going to consider the map that takes each student to courses that they are enrolled in at CU Denver this semester. And so this one would not be a function, since it's possible that one student is taking two different courses. And if that's the case, then that would violate this function relationship, since each student, if it's a function, should only be matched with one course. And again, since one student can take multiple courses, we could have one input being matched with multiple values in set B. So that would violate the requirement for a function. Okay, so some terminology with functions. The set A is called the domain. So these would be the set of all inputs in the function. The set B is called the codomain. And so this is where all of the outputs sit inside. And then the range is the set of all outputs of the function f. And so one thing you may be thinking to yourself is, I've never heard of the codomain. In calculus, we only talk about domain and range. What's the difference between the codomain and the range? So let's take a look at some examples to illustrate the difference between the codomain and the range. So let's say, first of all, let's consider the function which maps from the set of all real numbers to the set of all real numbers, where we are defining f as the equation. You take an input x and you map it to x squared. So here, the domain is the set of all real numbers. The codomain is also the set of all real numbers. Okay, but the range is actually just the values that get mapped to from this function. And so since the function x squared only has outputs that are greater than or equal to 0, the range is not all of the real numbers, but rather we could say the range is the set of all y in the real numbers, all real numbers such that y is greater than or equal to 0, since we are not going to map to any negative numbers with this function. So you can see here that the codomain is the set of all real numbers, whereas the range is just the set of non-negative real numbers. So the range is a subset of the codomain, and that is always going to be the case. So the range, it could be the entire codomain, but it has to be some subset that sits inside of the codomain. Okay, so let's take a look at another example. So now let's consider the function f, which maps from the real numbers minus 0 into the real numbers, where f of x is the map 1 over x. And so this notation over here means the set of all real numbers minus the number 0, since if we define this function and we define the domain as all real numbers, that actually wouldn't be a function because the element 0 would not map to any element in the codomain. So we need to stipulate that the domain here excludes the value 0. Now this is a well-defined function, and we see that the domain, right, that's going to be the real numbers minus 0. The codomain is the set of all real numbers. And then the range would be the set of numbers that are mapped to by this function 1 over x. And so this would actually map to almost every real number, except there's no value x when we define it as mapping to 1 over x, which is going to map to 0. So therefore, the range is the same as the domain in that it's the set of all real numbers minus 0, since there is no value of x which would map to 0 according to this function. And one more example to practice. Let's consider the function q. Okay, and this function q maps from the real numbers to the real numbers by taking, if the input x is a rational number, then we map to 1. If the input x is an irrational number, then it's going to map to 0. So in this case, the domain is the set of all real numbers. The codomain, that also is the set of all real numbers, but we don't map to every element in the codomain. Rather, we only map to 2 elements, 2 real numbers, either 0 or 1. So we would say the range here is the set containing the elements 0 and 1. Okay, that's it. Good luck on the quiz, and I will see everybody in class.